Hello everyone, this is Professor Lee. Let's solve this problem. In this problem, we're going to replace the loading by an equivalent resultant force and couple moment acting at point O. Alright, so let's see this figure. On our body here, discrete loading is acting. Actually, two different discrete loadings are acting on our body. One is downward, another one is upward. All right, so then let's specify the given information. For this, what we're going to do, we're going to follow the assumption of the discrete loading. A discrete load, we assumed it is only acting along only one axis, which is the length axis of the body. So here, therefore, we're going to use these horizontal directions as the length unit x along the body directions. Following the coordinate system from the problem, the length is given as feet here. What about y-axis? For the y-axis here, we can use the y-axis in terms of the loading function information. Loading function for the discrete loads, we're using the symbol w, small w. In terms of the unit of the loading function is what? Force per unit length. Following the unit system from the problem is pounds. Force per unit length is feet. That's the y-axis information. So here, x is given here. So let's take care of the given information. So loading function, first, we're going to divide this one as area 1 and 2. Because two different loadings are acting on the body. So here for the area 1 in terms of loading function here, at x, because the loading function is a function of length x. Therefore, x at 0 to 9 here, at 9 is given as what? 50 pounds per feet is given in terms of y information. But simultaneously here, we do see for the loading function of area 2, also at 9, same magnitude as what? 50 pounds per feet. 50 pounds per feet in terms of magnitude is given as here. From this, what we have to do, we have to find one single resultant force from the discrete loading. And also we have to find one resultant couple moment acting at point O. That's what we have to find. So we want to make one equivalent system, finding these one single resultant force and couple moment at point O. Okay, so to do so, let's start our solutions. Very first step, we have to define our coordinates. Since we're dealing with a 2D problem, so we need two coordinates, x and y, and also moment counterclockwise in these directions, x and y moment. These directions are going to be our positive directions. Then now, what we have to do, we have to deal with each discrete loading to convert each discrete load into the force. All right, then let's recall. What was the force from the discrete loading? The force can be found by the area under the loading. That's what we learned. And also the force will act at where? At the centroid. Centroid of the area under the loading. I want to make good word here. So here it must be centroid. Okay, so centroid. So our force can be calculated by the area under the loading and where it acts at the centroid of the area under the loading. That's what we know. All right, so then let's deal with this first area of the discrete loads. Okay, so first area, let's call that one as force of 1 from the area 1. So area 1, I brought here. Okay, so then the point here is starts from our coordinate point O. That's our origin as well, our starting point in terms of x. Our 0 starts in terms of x from that point O. because we have to read the geometrical information from that origin. That's important. All right, since we have to deal with the area to find the force from it, we have to deal with the area of the right triangle. How to find the right triangle information in terms of area? We need the base information. Okay, then let's read the base here. 9 feet is given from the problem. What about height? Height is y information, which is a loading function, which is given as 50 pounds per feet is given. That's our height of this right triangle as well. Therefore, force of 1, here force is a vector, therefore vector is there. But it goes down for the area 1, it all goes down, therefore, according to our coordinate definition, it should be minus. Then force from the discrete loads can be found by the area under the loading, which is area 1. Can be found by minus, don't forget, because in terms of the direction, and 1 over 2, because it's a right triangle, and base, which is 9 feet, and the height, which is 50 pounds per feet. That's what we took from the given information. It will turn out to be the pounds, which is the force from the loading. Therefore, if we calculate this one, don't forget minus in terms of direction, it's going to be 2 to 5 pounds will be the force under the right triangle loading. Then also we have to answer this question, where this acts. Where this acts under the loading. So here then we do know the answer is the centroid of the area under the loading. Alright, then now centroid, where the centroid of this right triangle will be located. We do know how to find it. It's going to be first, where is the right angle from the right triangle? Because from the right angle, how much? B over 3 much. Since we are dealing with area 1, let's call B of 1. Therefore, it's going to be B of 1 is 9 feet divided by 3. Therefore, 3 feet will be there. But we have to read from origin to how far the C of 1, the centroid of is located. Here, therefore, we have to read here 9. So we have to read this much. Starting from here to here, that's what we have to read. Therefore, 9 minus 3, 6 feet. At 6 feet, our force of 1 will act. That's how to interpret. Okay, then let's move to force of 2. Force of 2 will be provided from this reloading area under this loading here. Okay, our strategy is going to be same. So force of 2 will be calculated by the area of 2 here. So area 2 here, let's took here. Okay, so first of all, we need the base and height information to calculate the area of this right triangle. Okay, so here base is again 9 feet. And then height is this much. So we are going to read here 0 to this. We're going to just take absolute value in terms of the height. Therefore, 50 pounds per feet will be the height. All right, then let's hear 9 feet for the base. And then height was what? 50 pounds per feet. That's going to be our information for the area. So area will be found by, the force of 2 will be found by area under the loading of 2. But here in terms of direction, because the force is a vector, the force direction arrows all goes up, means opposite, it's the positive direction as we said, it's same direction. Therefore, the direction of F of 2 is actually positive from the discrete loading. All right, how to calculate the area of 2? Again, don't forget this is positive. So 1 over 2 for the triangle times base, 9 feet. And times height, which is 50 pounds per feet. Turns out to be what? Plus 2 to 5 pounds will be the force of 2 from the area 2 from the distributed loads. Then we still have to answer where it acts. So we do know the force of 2 will act at this centroid of 2 here. How to find the centroid of 2 here? Then first find the what? Right angle. So right angle, how far? B over 3 far. Therefore, let's call this is area 2, B over 2. B over 2 was what? 9 feet. Therefore, 9 divided by 3. Therefore, 3 feet will be this much length. But here we have to read from point O here, which was our origin. Where this acts from the origin here. So here from this one, let's take the given information. So from the origin here, how far? 9 feet. And here, this much was what? 3 over 9, B over 3, 9 over 3. Therefore, here, coming back to here, this was 9 feet. And this was 3 feet. Therefore, this from the 0 to centroid will be 9 plus 3 feet. Therefore, 12 feet. At 12 feet from point O, our force of 2 will act upward direction. How much? 2 to 5 pounds. That's how to interpret. So therefore, x of 2 will be starting from, again, we have to read the coordinates. Starting from 0, 9 plus how far? 3 feet far, the centroid will be located. That will turn out to be 12 feet from the origin. All right, so then let's take care of the entire shape using this body. So we brought the body outline with the blue color. And then let's indicate important point O here. All right, then I switched with the pink color because I'm going to start to indicate active forces from the distributed loading from area 1 and 2 we just converted. And we do know where they are acting. Okay, from the area 1, how much? 2 to 5 pounds much. Where? At 6 feet from 0. So here at 6 feet. So entire length is 18. Therefore, 6 should be here. So here from 0 to how far? 6 feet too far. Then which direction? Downward direction. Here, how much? 2 to 5 pounds will act from the distributed loading under the area 1. Then another force will act from the another area 2 here. How much? 2 to 5 upward direction because positive here. Where? At 12 feet from the origin. All right, so then here, again, entire length was 18. Therefore, 12 will be like this. So here will be 12. So 12 feet from the origin. So here then, upward direction, how much? 2 to 5 pounds will act from the distributed loading of the area 2. And therefore, we see here the resultant force, which are the acting on the body, will be found by force of 1 from the area 1, force of 2, area 2, summation of them. Then force of 1 was minus 2 to 5 pounds, and force of 2 was 2 to 5 pounds. Therefore, it turns out to be 0. They're going to be canceled out. Then what about the moment? Well, we have to find a couple moment about point O. So couple moment, the resultant couple moment about point O can be found by what? Summation of all the moments acting at point O. That's going to be because we're dealing with the two forces. Therefore, two forces, moments created by these forces at point O. We can add them together. Okay, then this one can be found by, let's come back to here. So here then, 2 to 5, here, we're going to use this formula, magnitude of the moment in 2D can be found by moment arm times absolute value of the force. And then in terms of the direction, we're gonna use right hand rule, thumbs up or thumbs down posture. Then what was the definition of the moment arm? Should be perpendicular distance from the point to the line of action. Therefore, 2 to 5 pounds from the point O, line of action, perpendicular distance. Therefore, 6 feet must be the moment arm. Therefore, 6 feet moment arm times the absolute value of the force 2 to 5. We just use this formula to find the magnitude. Then let's apply right hand rule. Thumbs up, thumbs down. To call this 2 to 5, it should be thumbs down posture, therefore minus. Then let's move to 2 to 5 pounds here. So again, the moment arm must be perpendicular distance from where? From the point O to the line of action, perpendicular distance. Therefore, 12 feet will be our moment arm. Then absolute value 2 to 5 of the force. And then let's apply right hand rule. To call this upward direction, we have to go to the thumbs up posture. That way we can call the 2 to 5 pounds upward direction. Therefore, positive. If you calculate this one, it's going to be 1,350 pounds times feet. That's going to be. Also, interestingly, we can also see this one. It's a very good review for this problem. We see 2 to 5 and 2 to 5, same magnitude, opposite direction, perpendicular distance, separated by the perpendicular distance. There are two forces, same magnitude, opposite direction, separated by the perpendicular distance d. They are actually a couple. Therefore, we can actually also find the moment from this one. It's like the moment, couple moment. So actually we can find the couple moment. Can be calculated by df. So here we see 12 minus c will be the distance, which is the moment arm, 6 feet. So therefore, 6 times 2 to 5 was the magnitude of this one. So I'm going to write pretty here. So I'm going to write 2 to 5 here. So 6 times 2 to 5 absolute value. Then we're going to choose either one to call this upward should be what? Positive. For this one also positive. Therefore, should be positive. So same result, 1350 pounds feet using this method as well. This was interesting problem. All right, so therefore, for our final answer, resultant force was cancelled out from these two forces, same magnitude but opposite direction from the display loading here. Therefore, was 0. However, we were able to find the resultant moment about point O here from each force, or using the couple moment method, was what? So here, following our three significant figures. So here, So following our three significant figures, 1, 2, 3 here, therefore 1.35 kilopounds times feet. That's how we can provide three significant figures for our final answer. That's about it. And thank you everyone. See you next time.